Hello everyone. Today we will continue with our topic lines and angles. Now, parallel lines and transversal. First of all, what are parallel lines? Parallel lines remain the same distance apart over their entire length. No matter how far you extend them, they will never meet. Now, what is transversal? A transversal or a line that intersects two or more coplanar lines, each at different points forming different angles, is called transversal. Here, you can see that line T is a transversal of two parallel lines L and M intersecting at two different points. And here, the 8 different angles are formed. Now, let us study each angle one by Now, what are interior angles and exterior angles? Angles formed inside the two parallel lines when a transversal intersects them are called interior angles, and the angles formed outside the lines are called exterior angles. Here angle 1, 2, 7, 8 are exterior angles as they are formed outside the line of intersection, and 3, 4, 5, 6 are interior angles. Corresponding angles. Now, what are corresponding angles? Angles that occupy the same relative position at each intersection where a straight line crosses two others are corresponding angles. And if the two lines are parallel, the corresponding angles are equal. Here you can see that if two lines are parallel and there is a transversal, then two corresponding angles are equal. Here angle 2 and angle 6 are equal corresponding angles. Angle 1 and angle 5 are corresponding angles. Angle 3, angle 7 are corresponding angles. Angle 4 and angle 8 are corresponding angles. Here in the figure it is shown that this angle and this angle would be corresponding angles because two parallel lines are intersected by a transversal forming the same relative angle. Now, alternate interior angles. Now, what are alternate interior angles? When two parallel lines are cut by a transversal, the two pair of angles on opposite side of the transversal and inside the parallel lines are alternate interior angles. Here you can see when two parallel lines are cut by a transversal and the alternate angles formed on the interior side of the parallel lines are called alternate interior angles. Here angle 3 and angle 6 are alternate interior angles and angle 4 and angle 5 are alternate interior angles. Alternate interior angles have same measure. Here you can see that here angle OFG and LGF are alternate interior angle. So their measure is same. And KFG and NGF are alternate interior angles. So their measure is equal. Next. What is alternate exterior angle? When two parallel lines are cut by a transversal, the two pairs of angles on opposite side of the transversal and outside the parallel lines are called alternate exterior angle. Here you can see two parallel lines are cut by a transversal and the angles formed on the opposite side of the alternate angles are called alternate exterior angles. Here angle 1 and angle 8 are alternate exterior angles. Angle 2 and angle 7 are alternate exterior angles. Here in this figure also you can see that KFJ and MJN are alternate exterior angles and JFO and LGM are a pair of alternate exterior angles. Next is interior angles on the same side of transversal. When angles formed on the same side of the transversal, when a transversal cuts two parallel lines are called interior angles on the same side of the transversal. Here you can see that 3 and 5 are interior angles and are on the same side of the transversal. So 3 and 5 are interior angles on the same side of the transversal. And on the opposite side 4 and 6 are interior angles on the same side of the transversal. Interior angles on the same side of transversal is also known as consecutive interior angles, allied angles, and co-interior angles. So you find in any question these three names. So these are the alternate options of or alternate names of interior angles on the same side of the transversal. Now, axiom 6.3. If a transversal intersect two parallel lines, then each pair of corresponding angles is equal. To understand this axiom, let's take converse of it. That is, if a transversal intersect two lines, then the corresponding angles are equal, making the lines parallel. So, this is the diagram for it. Here I have taken a line AD and on it I have taken 2 points B and C. Now I draw two rays BQ and CS in such a way that angle ABQ and angle BCS are corresponding angles. Now I have to show that the lines that will be formed would be equal. So now I extend these rays in the opposite direction. That is ray QB at point P and ray CS to point R. So when I extend these rays, the angles ABP and angle BCR would be equal. That means they would be corresponding angles. So I can say that when a transversal intersect two lines forming two corresponding angles as equal, then the lines would be parallel. Here you can clearly see that line PQ and line RS would be equal. Now, this axiom is also known as corresponding angle axiom. Axiom 6.4. If a transversal intersects two lines such that a pair of corresponding angles is equal, then the two lines are parallel to each other. Here you can clearly see that it is converse of axiom 6.3. Now to understand this axiom, we use corresponding angle axiom to find the relation between alternate angles, alternate interior angles, and prove that line AB and line CD are equal. In the given figure, you can clearly see that line PS is a transversal of line AB and line CD and it intersects at Q and R respectively. Now, according to the corresponding angle axiom, angle PQA and angle QRC would be equal. So I can give this equation as 1. Now we know that PQA and BQR would be equal. Why? Because vertically opposite angles. And now from 1 and 2 you can see that angle BQR and angle QRCB will be equal. Here you can see that PQA is equals to QRC and angle PQA is equals to BQR. So I can substitute QRC is equals to BQR. So angle QRC will be equal to BQR. It is alternate interior angles. Now if these two line angles are equal, then we can also similarly show that AQR would be equals to QRD. And when alternate interior angles are equal, that means the lines would be parallel. So here we understood that if a transversal intersects two lines such that a corresponding angle is equal, then the two lines are parallel to each other. Now this result can be stated as a theorem. Next is theorem 6.2. If a transversal intersects two parallel lines, then each pair of alternate interior angles is equal. So let's see the proof of it. Here we are given that if a transversal PS intersects two parallel lines AB and CD at point Q and R, we have to show that each pair of alternate interior angles would be equal. So the first pair of alternate interior angle here is angle CRQ and BQR, and another one is AQR and QRD. We have to show that these two alternate pair of alternate interior angles would be equal. So let's see how. So first we take angle AQP and angle CRQ to be equal because they are corresponding angles. Also AQP is equals to BQR because it is vertically opposite angles. So now from 1 and 2 we can clearly see that angle CRQ would be equals to BQR, because here AQP and AQP is both on in the both the equation on the LHS. So we can substitute these two angles as equal. So angle CRQ will be equal to angle BQR. Similarly, we can show that AQR would be equals to QRD. So we can show that alternate interior angles are equal when a transversal intersects two parallel lines. Theorem 6.3. If a transversal intersects two lines such that pair of alternate interior angles is equal, then the two lines are parallel. Let's see the proof of it. So here we are given that two lines AB and CD and a transversal PC intersecting AB at Q and CD at R such that alternate interior angles are equal, that is BQR is equals to CRQ, and we have to show that AB is parallel to CD. Let's see how. So we take here, first of all, what is given? CRQ is equals to BQR. Next we take AQP is equals to BQR. AQP is equals to BQR. Now it is vertically opposite angles. So from 1 and 2 we can say that CRQ will be equals to AQP. Yes, CRQ will be equals to AQP because they are corresponding angles, and corresponding angles are equal. That means that the lines are parallel. Thus, for lines AB and CD with transversal PS, corresponding angles are equal. Hence, AB is parallel to CD. Theorem 6.4. If a transversal intersects two parallel lines, then each of interior angles on the same side of transversal is supplementary. Let's see the proof of it. Here we are given that a transversal line PS intersects lines AB and CD at point Q and R respectively. And we have to show that the sum of interior angles on the same side of transversal is supplementary. That is, angle AQR plus angle CRQ is equals to 180 degree, and angle BQR plus angle DRQ is equals to 180 degree. So let's see how we will prove it. First of all, we take angle AQP is equal to angle CRQ because corresponding angles. Also, we know that when PS is a straight line and QA is a ray on it, then AQP plus AQR would be equal to 180 degree. Now from 1 and 2 we can substitute AQP as CRQ. So we get AQR plus CRQ is equals to 180 degree. That only we had to prove. AQR plus CRQ is equals to 180 degree. Similarly, we can show that BQR is equal plus DRQ is equals to 180 degree. Hence, sum of interior angles on the same side of transversal is supplementary. Is theorem 6.5. If a transversal intersects two lines such that a pair of interior angles on the same side of transversal is supplementary, then the two lines are parallel. Let's see the proof of it. So first of all, we are given that the transversal line PS intersects line AB and CD at point Q and R respectively, such that BQR plus DRQ is equals to 180 degree. Interior angles on the same side of the transversal are supplementary, so it is equals to 180. And we have to show that AB is parallel to CD. Let's see how. First of all, we take angle DRQ plus DRS is equals to 180 degree because PQ is a straight line and ray RD stands on it. So DRQ plus DRS will be equals to 180 degree. Also, we are given that BQR plus DRQ is equals to 180 degree. Now, substituting both the equations equal, we get DRQ plus DRS is equals to BQR plus DRQ, which gives DRS is equals to BQR. But they are corresponding angles. Here you can clearly see that DRS and BQR are corresponding angles. And when corresponding angles are equal, that means the lines are parallel. So thus for lines AB and CD with transversal PS, corresponding angles are equal, hence AB is parallel to CD. Thank you, and if you have any doubt, comment in the comment section.